Subtracting polynomials. Objective of this lesson to subtract polynomials. Let's take a look at this example. Tegla Larupe of Kenya was the first woman to cross the finish line of the 1994 New York Marathon. She completed 26.2-mile course in 2 hours, 27 minutes, and 37 seconds. In 1995, she won again with a time of 2 hours, 28 minutes, and 6 seconds. How much faster was her 1994 time? So we want to find out how fast she was, okay, compared to her 1994 time. Okay, let's look at how to subtract time. Remember, we did this in 6th grade. To subtract the difference of times, you must subtract 2 hours, 28 minutes, 6 seconds, and subtract 2 hours, 27 minutes, 37 seconds from that time. Okay? So what did we learn from that particular lesson? What we know is this. Okay? We have 2 hours, 28 minutes, 6 seconds, and we want to subtract 2 hours, 27 minutes, 37 seconds. And if you notice, okay, you cannot subtract 37 seconds from 6 seconds. So what do? We borrow 1 minute from 28 minutes. The minute that we borrowed, we are going to add to 6 seconds. So this now becomes 22 hours, 27 minutes, 66 seconds. Again, okay? We borrowed 1 minute from 28 minutes, and that's the reason why you end up with 27 minutes here. And the 60 seconds, or the 1 minute that we borrowed from 28 minutes, we added to 6 seconds. That made it 66 seconds. Now, if you notice, you can now subtract 37 seconds from 66 seconds. 29 seconds, 27 minus 27, 0, 2 hours minus 2 hours, 0, you end up with 29 seconds, okay? So Miss LaRupe's 1994 time was 29 seconds faster. So how do you use this when we talk about subtracting polynomials? So in the application that we just heard, like units were subtracted from each other. Similarly in algebra, when one polynomial is subtracted from another, only like terms can be subtracted. Algebra tiles were used to help you understand how to add polynomials. They can also be used to help you understand how to subtract polynomials. In the last lesson, we talked about adding polynomials using algebra tiles, and let's find out how now we can subtract polynomials using the same method by algebra tiles. We want to find 4x squared plus 7x plus 4, and we want to subtract the polynomial of x squared plus 2x plus 1 using algebra tiles. Okay? Let's first make a model of 4x squared plus 7x plus 4. Okay, diagram below, and she's going to show you in a few seconds. Then remove, okay, 1x squared tile, 2x squared tile, and 1 tile. So this is our diagram. 4x squared plus 7x plus 4. There you go, 4x squared, 7x plus 4. And then we want to take away x squared tile, a 2x squared tile, and a 1x squared tile. And that's the reason why this is put in a box or a square, and the arrow going out, meaning you want to take that away. Okay, the 2x squared tile, 2 we want to take away, and then 1 tile we want to take away, or the unit tile. Okay, so if we take the x squared plus 2x plus 1 away, this is what's going to happen, and this is what's going to be left. Take that away, take that away, and take that away. We end up with, okay, we end up with 3x squared, okay, 5x tiles, and 3 1 unit tiles, or 1 tile remaining. So when you subtract 4x squared plus 7x plus 4 minus x squared plus 2x plus 1, you end up with 3x squared plus 5x plus 3. That is using algebra tiles. And as we've discussed in the last lesson, okay, algebra tiles can be very useful when it comes to these types of problems. Okay, it can be very visual how you subtract polynomials, but again, it can be also at the same time very inconvenient if you're dealing with bigger polynomials. Okay, where the coefficients are a lot larger, and drawing algebra tiles is impractical. Okay, to subtract polynomials, then you can use the same methods you used to add them. Okay, so let's say we want to find 5x plus 9 minus 3x plus 6. Method 1, we subtract vertically. So 5x plus 9 minus 3x plus 6. You subtract 3x, you end up with 2x. Add 9 plus 6. Sorry. You subtract 6 from 9, you end up with 3. So the difference is 2x plus 3. That's the vertical method. And let's try the horizontal method. See, again, 5x plus 9 minus 3x plus 6. We need to remember that from what we discussed, there's always an invisible 1 lingering in this area right here. So what do we do with that invisible 1? We basically distribute it to 3x, and let me show that to you. There you go. Distribute that to 3x and distribute that to 6. Once you do that, you end up with 5x plus 9 minus 3x minus 6. Okay, because negative 1 times 3x is negative 3x. Negative 1 times 6 is negative 6. Okay, using the associative property of addition, we group 5x minus 3x plus 9 minus 6. And we end up with, you have 5x minus 3x. Those are like terms. We can subtract them. End up with 2x plus 3. Okay, from here to this step, okay, is the distributive property, which tells us that we can add like terms, and these are your like terms. When you add those two like terms, you end up with 2x. Okay, so that is how you subtract 3x plus 6 from 5x plus 9. Okay, now recall that you can subtract a rational number by adding its additive inverse. Okay, you can also subtract a polynomial by adding its additive inverse. Okay, and method 2 basically exemplifies that. A good example of adding its additive inverse. To find the additive inverse of a polynomial, it is necessary to multiply the entire polynomial by negative 1. Let's look at the examples below. You have negative 1, negative y as your polynomial. If you multiply it by negative 1, the additive inverse of negative y will be y. You have 4x minus 3. Multiply the whole polynomial by negative 1. End up with negative 4x plus 3. Again, if you notice, you are distributing the negative 1 to 4x. Okay, negative 1 times 4x is negative 4x. Negative 1 times negative 3 becomes positive 3. Again, you have 2xy plus 5y. Multiply that by negative 1. End up with negative 2x minus 5y. And lastly, 2x squared minus 3x minus 5. Distribute the negative 1. The additive inverse would be negative 2x squared plus 3x plus 5. Okay, again, let's go back here. To find the additive inverse of polynomial, it is necessary to multiply it by negative 1, and that's what we just did. Okay, and going back to the last sentence before that, you can subtract a polynomial by adding its additive inverse. Let's remember that, because in the next example, that's exactly what we're going to do. Okay, we're going to add its additive inverse when we subtract. Let's take a look at the example number 3. Let's find the difference of 7x plus 5 minus 3x plus 2. And remember that when we subtract a polynomial, we add its additive inverse. So going back here, the additive inverse of 3x plus 2 is negative 1 times 3x plus 2. We distribute the negative 1 to 3x, and we distribute the negative 1 to 2. We end up with 7x plus 5 plus negative 3x minus 2. Simplifying it further, we take out the addition sign, and we simply have 7x plus 5 minus 3x minus 2. Using the commutative property, okay, of addition, we now have 7x minus 3x plus 5 minus 2. And finally, using the distributive property, okay, and adding when adding like terms, you now have 7x minus 4x will give you 4x, 5 minus 2 will give you 3. And that is the simplest form of 7x plus 5 minus 3x plus 2. It's the difference of the two polynomials. Again, this is in simplest form because there are no like terms, and if you don't have any like terms, you cannot add 4x plus 3. Okay, let's look at example B. Was that example A? Yes, I'm assuming that's example A. Yep. Example B, you have 3x minus 2, 3x squared minus 5xy plus 7y squared minus x squared minus 3xy plus 4y squared. Okay. First, align like terms and add the additive inverse of x squared minus 3xy plus 4x plus 2. Okay. So we have 3x squared minus 5x plus 7y. There you go. We just copied it down. And then we are lining up x squared minus 3xy plus 4y squared right here. We're lining up all the like terms. Okay. And then what we did before, we are going to distribute the negative 1. Remember that there is an invisible 1 here, right there. And we are going to distribute that to x squared minus 3xy plus 4y. Okay. So the first thing, not that one. Okay, if you distribute that to negative 4y squared, okay, that's what's going to happen. But let's go back here. Let's go back again and let's redo that. Get negative n. Oops. Last time. Here we go. I got this right. Okay, you're going to distribute negative 1 to x squared. Okay, and then you are going to distribute negative 1 to negative 3xy. And finally distribute negative 1 to 4y squared. Okay, what you end up with will be negative x squared plus 3xy minus 4y squared. And then you simply subtract 3x squared minus x squared is 2x squared. Negative 5xy plus 3xy is negative 2xy. And 7y squared minus 4y squared is 3y squared. Okay, so the difference of those two polynomials is 2x squared minus 2xy plus 3y squared. Okay, and let's consider the last example, and let's talk about Lashonda. Lashonda plans to map and frame a picture. The area inside the frame is 3x squared minus 5. How much matting will Lashonda need? Let's take a look at what we know. We know that the area inside the frame and the area inside the frame, the area of the picture. So this is the area of the entire frame, okay? And this is your picture, okay? Nice looking picture right there, okay? So we know that the area inside the frame is 3x squared minus 5. That's what we know. We also know that the area of the picture is x squared plus 5. And we want to take that picture and bring it inside our frame, okay? What is being asked of us is this: how much matting will we need? And this is the matting right here. Okay, this is the matting that we will need. Okay, to be able for us to mount that picture. Okay, on this frame. So the area, what do we plan to do? The area of the picture is smaller than the area inside the frame. Okay. Subtract the area of the picture from the area inside the frame to find the area needed for the matting. Okay. In other words, from what we learned in the past, this is what is being asked of us. We want to find the area of the shaded region, which is this area right here. Okay, which is also the same as the area of the matting. And how do we find that? We find the area of the big rectangle, okay, which is the area of the frame, minus the area of the small rectangle, which is the area of the picture. This is the area of the picture. This is the area of the frame. Okay, so that is our plan. We want to find the area, to be able to find the area of the matting. We need to be able to get the area of the frame and subtract the area of the picture. Okay, And we know for a fact that the formula for finding the area of a rectangle is length times width, or base times height. Okay, so area of our matting will be length times width, which is the area of the frame, minus length times width, area of the picture. From there, let's look at what's given. Okay, we know that the area of the frame is 3x minus 5, and the area of the picture is x minus 5. We simply subtract that. Okay, and from what we learned, we simply add its additive inverse. Okay, negative 1 times x squared plus 5. We distribute negative 1. Okay, we distribute negative 1 to x squared plus 5. We end up with 3x squared minus 5 plus negative x squared minus 5. So we're distributing this to x squared. Okay, and we are also distributing this to 5, which gives us, okay, 3x squared minus 5 plus negative x squared minus 5. Okay, simplifying it further, we now have 3x squared minus 5 minus x squared minus 5. We simply took out the addition sign. And then using the commutative property of addition, you now have 3x squared minus x squared minus 5 minus 5. And adding like terms, we now have 2x squared minus 10. So the area of the matting will be 2x squared minus 10. That's how much LaShonda will need, okay, for her matting. And that's about it. Okay, write your summary on Google Forms and write a question you might want to ask in class about this lesson. Thank you.